Hello, and I'm delighted to be presenting at this very important Sem-Israel webinar. My name is John O'Donnell, and I'm CEO of yieldHUB. Hopefully, this talk will be informative and of value to you and your company. This is not a demo of our product, although there is one video later showing the stacking of thousands of wafers. The key challenge I'm going to address is how to keep on top of your yield as your volumes grow, hence scalable yield. How to do this efficiently and effectively. But who are yieldHUB? yieldHUB is an Irish company, 17 years in business. We were founded in 2005 and we're a leader in yield management systems. We leverage cloud computing, which has allowed top companies to analyze large amounts of data and solve many yield issues. I'm sure you're familiar with some of these names here, which is some of our customers. We've had the opportunity to work with many leading edge startups and work with teams from early phases to high volume production. Our staff is worldwide and offers support in all time zones, which is a valuable advantage when a company is in a competitive environment. Starting with me, all of our staff are passionate about yield analysis. So, scalability, what really does that mean? Scalable yield to me means scalable yield analysis. So, because as we know, even a few percentage yield improvement can be a huge gain. The cost of low yields can reduce a company's profit significantly. As you can see from the chart, even a few percent yield loss can result in hundreds of thousands of dollars of cost. They're a lost opportunity, as you have to run additional wafers to make up any shortcomings due to the lower yields. A yield management system, such as our yieldHUB system, can give a significant edge on your competition. So, there are many reasons why a yield management system can give you a competitive edge. Startups have a lot going on their quest for success. A good yield management system can allow the startup to focus on their core development and not have to worry about engineers manually gathering data and all the IT support required. Once again, time to market is a key to success, and a best-in-class yield management system that is scalable can accelerate that. Whether you in fact do your yield management system in-house yourself or not, I want to now discuss the key principles I have learned over the years. So, the assumption here is that you have a skilled number of product test engineers in your team. Okay, might only be starting with one or two, but what are the principles for a scalable yield for your company? Number one, the data infrastructure has to be secure. Any company wants to secure any applications they use and any data across multiple environments by maintaining complete visibility into all user folder and file activities. So it's very, very important. Also, you want to proactively identify and mitigate risks such as security threats, suspicious user behavior, malware, and others. Okay, so secure infrastructure is key. We have two main offerings. We have on-premise or cloud-hosted offerings. And obviously, it's important to have security strong in both. So on the cloud side, we chose Amazon Web Services as our partner. Amazon ensures, AWS ensures the safety of the cloud, the infrastructure that our services are run on. From a vulnerability detection and management perspective, we use a tool called Amazon Inspector, which is we employ to identify and allow for early patching of any vulnerabilities. We also use a tool called GuardDuty, a threat detection service that continuously monitors our AWS accounts and workloads for malicious activity. On the data transfer side, we actually offer secure FTP scripts for transferring data from subcons, although we allow customers obviously to have their own preferred method. So the next principle after security is, and I believe, automated data pipeline. So what does that mean? It means scripts for transferring data from the subcons are very important. They have to be reliable and with a specific directory structure which allows you to know where the data came from. and obviously secure, as previously mentioned. Now, it's interesting that scripts for automatically processing the data should be fast, and I believe they should be green. Okay, so this dimension of being green, it's interesting if you look at this topic. Green languages, or the greenest languages for data processing, are known to be as follows, and this takes into account the energy consumed, the time, and the memory. So number one is C, then you have Rust and C++. So there is a paper at the bottom here of this slide where the research has been presented on this. So it's interesting that these are the technologies, and there are many other software languages, including in the study. In general, what they found was compiled languages are much greener than interpreted or our virtual languages, I suppose. So compiled languages, for example, C, C++, Rust, ADA, virtual languages like Java, C#, and interpreted JavaScript, PHP, Ruby, and Python. And it's surprising how ungreen Python is. Okay, so we in our company, most of our development for most coding is done with C, C++. We also have moved in the last year and a half into Rust. We also use PHP, but we're moving further towards C++ for everything in the data pipeline. Okay, so a green pipeline. Now, one question I've been asked before is, what's the relationship between memory and being green? So, the memory consumption. And it's all about the DRAM usage when you're processing data. The RAM use. Energy doesn't seem to be correlated with peak memory usage, which is kind of surprising. The energy is more correlated with garbage collection, cache usage, register location, data management efficiency. So, automated data pipeline, that's also green. That's what we believe. Scalability in the database. So you can have a secure system, you can have an automatic data pipeline, but you also need a scalable database. Because as we know, big data is here. There are many multiple sources. Even for some startups, the scale of growth is phenomenal, especially in the IoT side. So here's a chart of one of our customers, their volume in 2019, 2021, and we expect 2022 will be much, much higher again. So with these kinds of volumes and with the data complexity, a scalable database that's able to manage the size and complexity of the data is really, really important. So whether you decide to do this in-house or get a vendor in, scalability, you need it to suit your needs. Okay, so we'll give you just an example here of the types of challenges we see quite often. We have customers with 500,000 die per wafer. So how do you handle that? We've one customer recently with 176,000 tests in a data log. I thought 20,000 tests is big, but that's phenomenal. 50,000 wafers to stack, so certain customers want to be able to do that. Or do 5 years of a parametric trend, and cases like that might be from, say, aerospace or automotive. So, so these are the kind of challenges that, that you can address with a scalable database. So the design is so important. Next one is clean data. So you can have all the security in the world, and you can have all the scalability and automation, but if the data isn't clean, then you have a problem. You won't be able to make reliable decisions. And this is just to capture the difference this makes. So before consolidating, what we call cleansing or consolidation of data at high volume, it's very hard to take any decisions that are reliable and trustworthy. After consolidation, it should be very clean. So imagine you had to make a decision about a test that's causing substantial yield loss. But you look at the data, there are multiple insertions for the same die. There's a bias towards the those failing parts in any histogram you do so, right? So imagine you're running hundreds of wafers a month, or even a quarter a month. Imagine sending a report to your customer that shows the CPK for these key tests, okay? And you realize you have to do this, but then you realize you don't have the data automatically cleaned, so you have to, an engineer is assigned to the task, takes him a few days to clean the data. And then you produce a report. But you can only, unfortunately, because of the scalability of your analysis system, you can only analyze a few lots. Okay? So, but what if the data had been automatically cleansed and ready for an immediate report? So clean data built into the system is very important. Okay? So I'll give you an example here of, this is a snapshot of a report where you have hundreds of lots of a product. Okay, this is the yield. So this is the range of yield of raw data. That means data that's just, hasn't been rescreened. There's rescreen steps here. Rescreen 1, 2, and 3. And imagine you have to analyze all that data and you haven't cleaned it. The importance of cleaning can be seen here in that you have, you can see how the accurate yield, when you take into account all the rescreen steps, etc., is a lot different to any of the other black spots in this case. Okay, so imagine if you had nothing to do, no engineering work to get to the last bit. Okay, so that's where automated clean data is very important to get you an accurate, for yield, but not just for yield, for in this case bins. So the yield I showed in the previous slide, underneath that there's bin performance. So in this case, top 5 bins, and you can see how the bins vary from the raw step to rescreen, etc. And you have the final version, the consolidated version. Imagine if you didn't have to do anything, that this was handled by your YMS to get to this picture. This now, remember, is over hundreds of lots. Okay, so on the right-hand side, you have a key parameter. And again, you have the distribution of the parameter for raw data, then for each rescreen step. And you have the final distribution, which is the one that would generate your information, say, as previously described about CPK, for example. So the CPK would be coming from this, which is hundreds of lots summarized for a parameter in this case. Okay, so clean data, automatically clean data is so important. Linked data. When you process final test package data in the relation database, you should link it up with tables from the same material. For example, water and wafer sort. This is really, really important when you're trying to be very, very efficient with engineering. So your wafers and lots should be linked automatically across manufacturing. Then reports like sensitivities of yield and fab parameters and a couple of clicks away, rather than searching one place, then searching another place and another place. Having it all linked together in one platform. Okay, so in the case of a platform like yieldHUB, you can select the data, and just do your correlation. You don't have to worry about the linking; it's already done. In the case of yieldHUB, that means you can have a single platform for all your data from watt through to wafer sort final test. All that data is linked and analyzable straight away. Drillability is very important. What we mean by that is high level to die level. From a yield report, being able to, within seconds, get down to a single die. Okay, it is possible, and again, it's the linking of the data that enables the linking vertically in this case that allows you to drill down within seconds from a yield report covering say hundreds of lots. You can be down to a single die within seconds. These days, a fundamental principle of any collaborative system, which any yield management system should be, is it's web-based. So in this case, when it is web-based, for example, a dev engineer in Israel could add comments, images, documents, and everything to yieldHUB, for example, to help sustaining engineers in Taiwan solve problems quickly themselves. So the collaboration, being online, now it could be on-premise behind a firewall online, or it could be on the cloud. But the collaboration, a fundamental principle of a scalable system, is that it's web-based for collaboration. Okay, and within our system, yieldHUB, this, for example, means that every analysis can be shared in one click. And the sharee receives an email and a link with an exact replica of the interactive analysis, not just a static report, but it's interactive. So the engineer in Taiwan can continue on and share back if they want to. So, for scalability, web-based UE. For scalability in teams, collaboration across continents, it needs to be web-based. Direct analysis. So what we mean by that is often traditional analysis flow is shown where you find data, you find step 2 is find additional related data, then you go through steps of downloading data, running a script, creating a report, tweaking the script often, creating a report and recommending the fix. Okay, so that's traditionally what needs to be done. You download the data onto your laptop or your desktop, etc. With yieldHUB and similar platforms, the flow is different. You find the data 1 and 2. When you look for data, say Microsoft data, you can see the data also in the same table. You can link to it. Links the data from what data, final tests, WaferStar, module data, system data if needed. So all the data is straight away in front of you, and in fact the reports are already available to be run. And so you really are shortening the decision cycle here to very few steps. Okay, we're told this saves 30% of engineering time versus using tools like available tools out there. A platform like this where everything is ready right in front of you. There's no downloading of data needed. Even though if you want, you can if you want, but most people don't need to. You don't need to. It reduces meetings, speeds up fixes. So you can imagine this really cuts short your decision-making time. And another customer says it saves 25% of their engineers' time. What that really means is that you get an extra engineer for every 4 engineers, you have an extra engineer. You can stack, in this case, they could stack 1,000 wafers if they need to, okay? And here's an example of stacking on an iPhone. And here there's 20,000 wafers stacked. That's like hundreds of gigabytes of data behind it. Because of the way, the fact that all the data at the server side, power of the server side means you can do this kind of stuff with a system like yieldHUB. So you search and go. And I'll give you an example now of this happening in real time. This is what the interface would look like. In this case, there are 7,152 wafers. So it's been chosen just to do an analysis on the web, and you've been offered to add some extra information to the report. Okay, so just in this case, you can let it run in the background, but we'll just let it run on the web here. So here we have, so what we're doing is we're stacking 7,000 and more than 7,000 wafers and getting a bin analysis of it as well. So in fact, there are nearly 13 million die involved here. Okay, and it's broken down all the results by site. And you can see here there are all the different bins that are bin information here. Okay, so software bins, in this case it's software bins, and also it breaks down the bins by site. So here we have the yield of each XY for those 7,100 wafers. You can see that. And you have zone analysis on the right. Okay, so this is the kind of speed that's possible. It's even, so, and also there are other things you could do, like a composite wafer. This analyzes effectively the bin performance at each XY. Okay. So this is the kind of scalable and direct analysis possible in a platform like yieldHUB. Here are stacked bins across all 7,000 odd wafers. Okay. So, and then you can also maximize these charts and have a really deep look at it. Okay. So for each XY again, you get the bin information. Okay, so finish now in a second. No. So the principles, just to summarize the principles so far, we have secure infrastructure, automated data pipeline, which I call green, scalable database, clean data, linked data, drillable data, web-based UE important, and direct analysis, okay? And what are the advantages in all this if you were to employ a vendor to have this system for you, a vendor like yieldHUB? Well, a vendor is going to be agile, supported, and they're going to have some thought leadership all the time. So agile means develop new capabilities when needed, scalable to grow with you yourself, and there are resources on tap for, say, new capabilities required. For support, there's support contracted, dedicated specialists, and who have a wide view of a changing environment, and thought leadership, up to date with industry best practice, common issues and variations already solved, innovative solutions to go beyond the industry standards. So a company like us would be dealing with like dozens of companies every week and would have some great feedback from those, great ideas, and a really good roadmap. So the innovation side, the likes of yourselves are top performing semiconductor companies. You have access to top innovation, top yield management vendors innovate as well and have a strong roadmap. And examples from yieldHUB, just some examples here of the type of innovation we have done in the past with customers and are available for customers these days. Also, the fact with the likes of a platform like yieldHUB, there's a low cost of proficiency in the system because you learn one system. Remember, all the different stages can be of manufacturing can be on one platform. There are common methods throughout the platform, so you're not learning many tools and all that. Just faster onboarding of new engineers because it's easy to learn. I'll just give you some examples of what customers have found with our platform in particular. This is from several years ago. It's from a real internal presentation by a customer a few years ago. It's a bit blurred, but it basically says that they save $200,000 a year by using. This is really by having direct analysis of high volume and the impact that can have on making decisions quickly and saving serious yield from the yield loss. Okay, so they just did that. They've got 100 products. This is just one product. Okay. So this is a comment by one of our customers. This is from Kasia, who's in Microchip. And without reading the whole thing, they have thought about bringing this thing in-house, but they always say yieldHUB is just faster, easier, faster, better, and more cost-effective. Okay. Then Matt from Movandi in California, who has often these startups in California, they come from big companies where they have exposure to other systems in the past. He thinks our system is sensibly designed from a usability perspective, and he can do very quick experiments even before meetings, so he says. And finally, Shane from DisplayLink, the cleanliness of the data. So they're a very exciting company. They were actually bought by another company recently, but we worked really hard on cleansing for them, and that has really had an impact on every other customer since. They had complex chips of hundreds of tests and high volume and complex operations, and the data needs to be cleansed, and we manage that. So we manage that at high volume. Okay. So a bonus principle I would is to integrate a yield management system and an MES system. This is really about putting lots on hold. And a system like yieldHUB can automatically detect when a wafer should go on hold, and this can be read by an MES system, so the actual wafer is put on hold. So that's an advantage of such integration. Similarly, an end of lot trigger from the MES system can be sent to a yield management system like yieldHUB, and that can trigger yieldHUB to send a report to engineers. So that's my last slide, and thank you very much.